Hello everyone, welcome to Coders Camp. We are at 13th day of October Lead Code Challenge, and the problem we are going to cover in this video is construct binary tree from pre-order traversal. So we have already covered a similar problem, that is constructing a binary tree from pre-order and in-order traversal, and this is kind of a pretty similar version with only pre-order traversal. So the input given here is pre-order traversal of a binary tree, and we have to return the actual structure of the binary tree. So let's understand this with an example. So here is the pre-order traversal of a binary tree given in the problem statement. And as we all know, pre-order traversal is nothing but traversing the binary tree starting with root and then goes to left and then the right child. So from that, clearly we can identify that the very first integer value given in the input array is going to be the root of our binary tree. So we are going to place the first element as our root. So from there, we have to construct our binary tree with rest of the integer values given in the array. So how do we do it? The property of a binary tree is all lesser values will be placed towards the left side of the binary tree, and the values towards the right side of the binary tree would be greater than the root value. So using this logic, we are going to place the rest of the elements in the array in our binary tree. So moving to our next element 5, which is obviously less than 8. So it goes towards the left side of our binary tree. So there comes 1. 1 is going to be again lesser than 8. So it is going to first start from the root node and then travel to the left side node. Here the left node is 5, which is again already greater than 1, which means 1 should go towards the left side of 5, because obviously 1 is lesser than 5. So there comes the next element 7. 7 is actually less than 8, so it goes to the left side of our binary tree, but on the left side the first child is 5. 7 is actually greater than 5, so 7 should go towards the right hand side of our 5. So similarly, the next node is 10. 10 goes to the right side of the binary tree since it is greater than 8. And again, the next node is 12. So if you see 12, 12 is actually greater than 10. So it should go to the right side of 10. So the left node will be null because we don't have any other elements left in our array. So 12 goes to the right side, right child of our binary tree. So this is how we construct our binary tree. So again, we are going to do it in a very simple way, calling it recursively. Every time we are going to check whether the value is less than the root value or greater than the root value. If it is less than the root value, then we are going to place it towards the left side of our binary tree. And we keep doing it recursively because we check if the node is null, then we directly place it. If not, we check the value of the left child, considering that as root, and then place our next node accordingly. Same goes with the right hand side of the binary tree. So hope you're understanding this concept. This is going to run at big O of n log n time complexity, because n is going to take to iterate the given integer array and log n is going to take to check where to place our node in our binary tree, because if it is less than root node, it is going to take only to check the left side, or it is, if it is greater, then it is going to check only at the right side. That is why it is going to take log in time. So hope you are understanding this concept. Let's go to the code now. So let us have a helper method which is going to help us to insert our nodes into binary tree. So what are we going to do is we are going to iterate our given input array, and we are going to call our helper method to place that particular integer into our tree. So before that, let us declare a node, and for each value we are going to create a node and insert it into our binary tree, and finally return the root of our binary tree. So this is set in the main method. Let's concentrate more on the helper method now. So let us have the base condition that if the root node is null, then we are going to simply return what is the value as the complete tree. Else, if it is not null, then it's time to check the value and compare it with the root value. So we are going to check if it is greater, if the root value is greater than the current value, then we are going to place it towards the left side of the node. So what are we going to do is, we are going to call the left side of that particular root node and insert it. If not, it is going to go towards the right side of the tree. And finally return the root of the tree. So yes, this is it. Let's run and try. Yes, let's submit and try. Yes, our solution is accepted and we have done with our today's coding challenge, and this solution runs in 1 millisecond. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.